Wool is one of the oldest textiles ever used by humans, worn for thousands of years as protection against cold, wind, and harsh climates. Yet the way raw sheep wool becomes smooth clothing today is a massive industrial journey that blends farming, mechanical processing, chemistry, and precision manufacturing. What begins as a greasy, dirt-filled fleece on a living animal must be transformed through shearing, sorting, washing, drying, carding, spinning, and finishing before it ever becomes a sweater, jacket, or blanket. Behind every soft wool garment lies a long chain of machines and skilled labor, turning a natural fiber into a reliable global product. And today on the How Factory, we're going deep into the world of wool to see exactly how sheep wool is sheared, cleaned, and turned into clothing. Humans began domesticating sheep thousands of years ago, and wool quickly became a revolutionary material because it could be harvested repeatedly without killing the animal. Ancient civilizations in the Middle East and Europe built entire economies around wool, and during medieval times, wool trade helped shape cities and empires. Even today, despite synthetic fibers, wool remains unmatched for warmth, breathability, and natural insulation, a living fiber designed by nature for extreme environments. The process begins on sheep farms, where wool production starts long before shearing day. Sheep breeds are selected for fiber quality, fleece weight, and climate suitability. Merino sheep, for example, are famous for fine, soft wool used in clothing, while other breeds produce coarser fibers suited for carpets and insulation. Farmers manage nutrition and health closely because wool quality is directly affected by stress, disease, and diet. Clean pastures and proper parasite control help reduce contamination in the fleece. Shearing is the first major step, and it's both physically demanding and highly skilled. Sheep must be shorn at least once a year, sometimes more depending on breed and climate. Professional shearers work quickly to remove the fleece in one continuous sheet while keeping the sheep calm and avoiding cuts. Modern shearing uses electric clippers with sharp combs that slide through the wool close to the skin. A skilled shearer can shear a sheep in just a few minutes, producing a large fleece that may weigh several kilograms. Once removed, the fleece is thrown onto sorting tables. This is where the first major quality control happens. Not all wool on a sheep is equal. Wool from the shoulders and sides is usually the softest and finest, while wool from the legs and belly is coarser and often more contaminated. Workers separate the fleece into grades based on fiber diameter, length, and cleanliness. Vegetable matter like grass seeds, burrs, and straw is removed as much as possible. This sorting stage directly affects the final product. Fine wool becomes clothing, while lower grades may become blankets, felt, or industrial materials. After sorting, wool is packed into large bales and shipped to scouring facilities. Raw wool, known as greasy wool, contains lanolin, dirt, sweat salts, and debris. Lanolin is a natural wax produced by sheep that protects the fleece from rain and harsh weather. While lanolin is valuable, it must be removed for most textile uses. Scouring is the washing process that transforms greasy wool into clean fiber. Wool enters large industrial scouring lines where it moves through a series of washing tanks filled with warm water and detergents. Mechanical paddles gently agitate the wool to release dirt and oils without damaging fibers. Temperature control is critical. If water is too hot or agitation too aggressive, wool fibers can mat together and felt prematurely. If washing is too mild, oils and dirt remain, affecting dyeing and spinning later. As wool exits the scouring baths, it passes through squeeze rollers that remove excess water and contaminants. The dirty wastewater is treated and filtered. Lanolin is often recovered from the wash water using separation systems, then refined and sold for cosmetics, skincare products, and industrial lubricants. After scouring, wool must be dried. Large drying ovens or belt dryers use controlled hot air to remove moisture evenly. Wool must be dried thoroughly but gently. Overheating can damage fibers, while residual moisture can cause mold during storage. Once dry, the wool is fluffy, lighter, and much cleaner, but still not ready for spinning. Next comes carding, one of the most important mechanical steps. Carding machines take loose wool and comb it into aligned fibers. The wool passes through rotating drums covered in fine metal teeth that separate tangled clumps and straighten fibers. This process removes remaining dirt and short fibers. Carding transforms wool into a uniform web that is condensed into a thick rope-like strand called a sliver. Depending on the final product, wool may undergo combing after carding. Combing is used for fine, smooth yarns, especially for clothing. Combing machines remove short fibers and align long fibers more perfectly, creating a clean, uniform sliver ideal for high-quality yarn. The removed short fibers are not wasted. They may be used for felt, insulation, or lower-grade textiles. Once fibers are aligned, spinning begins. Spinning is where wool becomes yarn. Slivers are drawn out and twisted on spinning frames. The amount of twist controls yarn strength and softness. High twist produces durable yarn for outerwear, while lower twist creates softer yarn for sweaters and scarves. Spinning is carefully controlled to prevent breakage and ensure consistent thickness. Sensors monitor tension and diameter continuously, producing uniform yarn across thousands of meters. After spinning, the yarn is wound onto cones or bobbins. It may undergo additional treatments such as plying, where multiple strands are twisted together for strength and texture. Yarn is then prepared for dyeing. Dyeing can occur at several stages: fiber dyeing, yarn dyeing, or fabric dyeing. For consistent color and premium clothing, wool may be dyed as fiber before spinning. Large dye vats immerse wool in carefully controlled dye solutions. Temperature, pH, and time are monitored closely to ensure even color penetration. Wool absorbs dye beautifully due to its natural protein structure, but uneven dyeing can create streaks or patches, so agitation must be gentle and uniform. After dyeing, wool is rinsed and dried again. It is then ready for fabric production. Fabric manufacturing can involve weaving or knitting depending on the final product. Knitting creates flexible garments like sweaters and socks, while weaving produces structured fabrics for suits, coats, and blankets. Modern textile mills use computerized knitting machines and high-speed looms capable of producing complex patterns with incredible precision. Once fabric is produced, it undergoes finishing, a series of treatments that improve feel, appearance, and performance. Wool may be washed again to soften fibers and remove processing residues. Fabrics may be brushed to raise a soft surface or heat set to stabilize shape. Some fabrics undergo shrink-resist treatments to prevent wool from shrinking and washing. This is especially common in machine-washable wool garments. Quality control continues throughout fabric production. Fiber diameter, yarn strength, fabric density, and color consistency are tested repeatedly. Wool garments must meet strict standards for durability, softness, and comfort. Any defect in the fiber can appear later in the fabric, so monitoring begins at shearing and continues until final inspection. After finishing, fabrics are cut and sewn into clothing. Garment factories use pattern cutting machines and skilled sewing lines to assemble pieces into finished products. Wool garments often include linings, reinforcements, and careful seam construction to maintain shape. Final garments are steamed, pressed, and inspected before packaging. Behind the scenes, wool production also involves sustainability considerations. Wool is renewable, biodegradable, and naturally insulating, making it a preferred fiber for eco-conscious consumers. However, wool processing requires water, energy, and chemical management, especially during scouring and dyeing. Modern facilities invest in wastewater treatment, heat recovery, and efficient machinery to reduce environmental impact. What makes wool manufacturing remarkable is the transformation from living animal fiber to precise industrial textile. Raw wool is messy, oily, and inconsistent. Yet through sorting, washing, alignment, and spinning, it becomes uniform yarn and fabric that can be tailored into modern clothing. Wool retains its natural advantages: warmth when wet, breathability, odor resistance, and durability. Qualities synthetic fibers still struggle to fully match. From ancient shepherds shearing sheep with hand tools to modern scouring plants and automated textile mills, wool has remained one of humanity's most important materials. The process has evolved, but the core principle remains the same. Turn fleece into fabric without destroying the fiber's natural strength. From shearing sheds and sorting tables to washing tanks, carding drums, spinning frames, dye vats, and weaving machines. The journey of wool is a fusion of agriculture and industrial precision hidden behind everyday clothing. And that is exactly how sheep wool is sheared, cleaned, carded, spun, dyed, woven, finished, and turned into clothing, transforming raw fleece into soft, durable garments worn all over the world. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the farms, factories, and systems behind the materials we use every day.